Okay, this is part 2 from 10.1 and 10.2. So here vectors in the plane and in space. Theorem: for any vector A and B and C in V3 and any scalar D in R, the following hold. So we have, okay, so for addition, if we have vector A plus vector D, it is the same thing if we have vector B plus vector A. If we have vector A plus vector B plus vector C, same thing if we have vector A plus vector B plus vector C. If we have vector A plus 0, it will be vector A. And if we have vector A plus negative vector A, that means same direct, it means vector A plus negative A, which is in the opposite direction, so it will be 0. If we have D multiplied by vector A plus vector B, it will be, so D multiplied by A multiplied by B, D A plus D dB. 1 multiplied by vector A, it will be A, and 0 multiplied by vector A, it will be 0. Vector, standard basis vectors. We define the standard basis vector I, J, and K. So it like so A it is refers to X, and J to Y, and K for Z. So it is like this one. We have this Y, here Z, and here X. We can define it as J, K, I. So I, it is 1, 0, 0, J 0, 1, 0, and K 0, 0, 1. A, J, and K form a basis vector, a basis for V3, since we can write any vector vector A equal, I think it is equal, or it is like something related to V3 uniquely in terms of I, J, and K as follows. So if we have vector A, we have A1, A2, and A3. So it will be like A1 with J, A2 with A1 with I, A2 with J, and A3 with K. So here like it is for X, for Y, and for Z. For any non-zero position vector A unit vector having the same direction. So we have this formula, which is called unit vector U equal vector A over magnitude of vector B. So this is vector A, and this is magnitude of vector A. So let's take example. Find a unit vector in the same direction as 1, -2, 3, and yeah, so 1, -2, 3 as the product of its magnitude and unit vector. So to find it, it is like, yeah, we can, yeah, so it is like vector A. We have A1, A2, and A3. To find the unit vector, you have to find, we already have the vectors, and you want to find the magnitude. So it is like 1, -2, 3 over magnitude of 1 square plus -2 square plus 3 square, and it will be yeah, so it will be, yeah, so the here I have to write the result of vector A, of magnitude of vector A, which is 1 square plus -2 square plus 3 square. It will be square root of 14. So unit vector, it will be 14 over 1 minus 2, 3. And you can write it like 1, 2, and 3. That's this. And also for this exercise, same thing. Find 2 unit vectors parallel. So that means we have A, and we have B, and we have C. Yeah, that means if I want to find the unit vector for A, or even for B and for C, same thing. So we will stop here. So just we take the summary. We so we learned that we have something called vector A, which is, if we have 2D, we have A1 and A2. If we have in 3D, it will be A1, A2, and A3. We learn that if we have here, for example, here this vector A, and we have 2A, it will be like this, 2A. If we have, if we have vector A and vector B in same direction like this, or in opposite direction like this, that means they are parallel. They are parallel to each other. And we find that, yeah, if we have U and -2U, that means U and -2U, it will be in the opposite direction. If we have U and -U, the resultant will be 0, because U plus a -U, it will be 0. Yeah, same thing. Yeah, to find the magnitude of vector A, it is A1 square plus A2 square plus A3 square if we treating with 3D and 2D, it will be just A1 and A2. Yeah, we learned the multiplication. If we have A1, like if we have AB, so that means B minus A. That means B1 minus A1 and B2 minus A2. Yeah, same thing. Subtraction. A1 plus B1. I'm sorry. And A2 plus B2. Here, subtraction. A2 plus B1 and A2 plus B2. A1 here, I'm sorry. And for scalar multiplication, C multiplication will be CA1 and CA2. Yeah, just that. So this is the end of section 10.1 and 10.3, and finally we have unit vector, which is vector A over the magnitude of vector A. Yeah, thank you.